Okay. All right, so the pi over 4s cut each quadrant in half. And it's kind of nice to have them in here all together. Make our little butterfly family here. So all of these locations have a reference angle of 45 degrees or pi over 4 radians. Okay. Moving on to pi over 3. This would be all of the 60-degree locations. Nope. That's a mess up. And so no matter what, if I am given an angle measure, it doesn't matter if it's positive or negative, if the angle is given to me in radians with 3 as the denominator, I know that its reference angle is always going to be pi over 3, which is the same as 60 degrees. And then I have my 30-degree angles, all of the pi over 6 angles. This is the smallest angle that's on the unit circle. It's repeated the most number of times. It's the one that has the largest numerators, I guess you could say, throughout the circle. Okay, so breaking it down like this, thinking of it in terms of little butterfly families, whatever works. It's just a good way to work with the angles and kind of get more familiar with them. Also, we need to get more familiar with the fact that we're counting in terms of the fractions. And so let's say if I've got 6s, and I know in the past I kind of say it quickly without a lot of thought, but I do want us to be more comfortable with, adding a pi over 6 each time, so that 12 pi over 6 is equivalent to 2 pi. That's one whole rotation. Well, I can keep going in the world of counting. This would be, 13 pi over 6. This one would be 17 pi over 6, 18, 19, 20, 21, 22, 23. This would be 23 pi over 6. So again, I arrive here, 24 pi over 6. Do you recognize that 24 pi over 6 is equivalent to 4 pi if I reduce that fraction? So 4 pi is 2 whole rotations. So we kind of want to be familiar with our fractions and just be comfortable with them and not think that it's something that I can't understand when I'm thinking in terms of radians. All of this is just to prepare us to be able to think in terms of radians in a more comfortable way. We're so used to degrees, but everything in pre-cal and calculus deals with radians. That's the default. That's the preferred measurement. And so we want to get more comfortable with that. Now, as we go forward, we might be asked to find different things. It first asks us here to find out which quadrant these lie in. And then I'm going to go a step further and say, what is the reference angle? And we want to give this in radians. So what is the measure of the reference angle? Okay, 2 pi over 3 lands me in what quadrant? 2 pi over 3 is located, yes, good, in the second quadrant, somewhere over here-ish. It's in quadrant 2. And the reference angle is what? I don't really have to think about it too much because of the fact that it has a 3 in the denominator. So the reference angle is going to be pi over 3, 60 degrees. The reference angle would be this in here. All right, negative pi over 4 is in what quadrant? Negative pi over 4. Positive pi over 4 would be here, right? So negative pi over 4 is going to be right here in this spot. So negative pi over 4 is in quadrant 4. What is the reference angle for that? It's pi over 4. Good. It's 45 degrees or pi over 4 radians. Remember, your reference angles are always positive, and it's referring to that angle that gets me back to the x-axis. So theta in there. So even though the angle, I went to a negative location, the angle measure itself, the measurement's not negative. It's just the location of that angle is negative. All right, you do the next two. 3 and 4, do by yourself. Check with your partner. Tell me the quadrant where it's located, and tell me the reference angle measure. In what quadrant is it located? And what is its reference angle? Okay, so number 3 over here, 13 pi over 6. That's past one whole rotation. So that's going around once and then going a little bit more. And it lands me right here in quadrant 1. So 13 pi over 6 is located in quadrant 1, and the reference angle is going to be pi over 6. that shouldn't be too difficult for me because whatever the denominator is, that will be the denominator for my reference angle. And it's always just going to be 1 pi over that denominator for the reference angle. Okay, so number 4 asks for negative 5 pi over 3. I always like to locate the positive one first. So I counted and located positive 5 pi over 3. And so in my mind, as I'm traveling to that location, I'm starting here and I'm passing through I'm passing through 3 quadrants on my way to get to positive 5 pi over 3. And then it's the first mark after I get into the third quadrant. So I'm going to do the same thing, but I'm going to go backwards. So from my starting location, go down first, go past 1, 2, go all the way through 3 quadrants, and then to the first mark. That will land me at negative 5 pi over 3. So this is the location for negative 5 pi over 3. It's in quadrant 1. The reference angle, pi over 3. Whatever the denominator is here, that's going to be the denominator of my reference angle every time. Questions so far? Okay, so if we look down at the next 2 examples there and want to immediately and very quickly, as fast as possible, state the reference angles for each of those, can we do that? The reference angle here, pi over 4. The reference angle here is what? You may take a stab at it. Pi over 6. Very good. I don't need to locate the angle. I don't need to know what quadrant it's in. I don't need to go through all that trouble. If all they're asking for is the reference angle, then I don't have to go through any location stuff. I can just immediately know it's going to be whatever the denominator is. Now, locating it would be take us a little bit more work. So let's go back and just fill in. 10 pi over 4 would be 8 pi over 4 is 1 whole rotation. So 10 pi over 4 actually lands me at a quadrantal angle. So it's not in a quadrant because it's quadrantal. So that's a good thing to remember. For 11 pi over 6, and I'm going in the negative direction. Here's positive 11 pi over 6. So negative 11 pi over 6 is going to be here in quadrant 1. Okay, so I'm going to stop us there